Previously, we've discussed solving systems of linear equations with the graphing method. Let us recall that the solution to a system of linear equations, for example, the solution to this system, is the intersection point of the two lines. We saw in our graphing video that this method can be time-consuming. It requires that you have grid paper, you got to draw nice, straight, clean lines, and it has potential of not being as accurate if you need it. So there are other ways to find the point of intersection or the point that lies on both lines. So we'll now begin to look at an algebraic method for solving linear systems. The algebraic method we're going to first look at here is the substitution method. And it's a four-step process. If you practice this enough, you should get fairly comfortable with it. The first move is you need to isolate one of the variables in one of the equations. Doesn't matter which one, it's your choice. Second step is then once you've done that isolation, whatever that's equal to, you plug that result into the other equation. This will give you a one variable equation for which you can solve. Once you solve that equation, you then plug the result of that equation, that numeric result, into one of the original equations to get the value of the other variable. Once you've got the value of each variable, then you write your solution as an ordered pair. Let's see an example. Solve the following system using the substitution method. So we've got this here. Now the first step in the method is to isolate one of the variables in one of the equations. So you can choose to isolate this x, this y, this x, or this y. It's completely up to you, it's your choice, but we want to choose in a way that makes it easiest for us. So the coefficient of this x is -3, the coefficient of this y is 2, the coefficient of this x is 2, and the coefficient of this y, if you were to rewrite this as addition, would be -1. In general, I don't want to create fractions. So if I can find a variable with a coefficient of 1 or -1, that's the best one to isolate, because then you won't have an expression with fractions in it. So let's isolate this y right here. So step one, we're isolating this y. Your first move would be to subtract 2x from both sides, giving you -y equals 5 minus 2x. And then, of course, y is still not fully isolated. We need to divide both sides by -1 to isolate y. And that gives us y equals -5 plus 2x. This right here was step one. We isolated one of the variables in one of the equations. In this case, we isolated y. It could have been x. It's really up to you, whatever's easiest. Second step is to take this result and plug it into the other equation for, in this case, y, because it's y equals this thing. So we plug this thing in for y in the other equation. That's step two. The new equation we get is -3x plus 2 times, in place of y, we've got -5 plus 2x. Notice I've got parentheses around the -5 plus 2x because you want to double that whole thing, equals -6. And as we mentioned, this now creates a one variable equation. Having a one variable equation, we can solve for, in this case, specifically for x. That's step 3. So first we want to do some distributing here. We get -3x minus 10 plus 4x equals -6. Our next move would be to combine like terms. -3x minus 10 plus 4x is x minus 10. And we still have that's equal -6. And then if you add 10 to both sides, you get x equals 4. Of course, 4 is not our solution. However, it is the x coordinate of our solution. So let's write that up here. We've got 4 comma something. To find out what that something is, take this 4, which is a value of x, and plug it in, and it doesn't matter which one. It could even be this one right here. Plug that in for x to solve to get the value of y. So y equals -5 plus 2 times, in place of x, I've got 4. You could have plugged that value of x equals 4 into this equation or this equation. I just chose this one because this one is the same as that one, and it already has the y isolated, so it just makes it a little bit easier. So when we go to solve this, you just have to do arithmetic. Y is already isolated. Of course, we got y equals -5 plus 2 times 4 is 8, and -5 plus 8 is 3. That is the y coordinate of our solution. So now we'll write that in up here, and here is our solution. Even though we did not draw it, I now know, no matter what exactly these two lines look like, I know that they intersect at the point 4, 3. One of the strengths of this algebraic method is you do not need any graph paper. And if, for example, let's say the solution was 1.381, 4.22258, you would get that exact answer doing this algebraic method, whereas you wouldn't be able to see something like that if you drew it graphically. But you'll also see that sometimes this algebraic method has its limitations. For example, if I were to solve the equation, the linear system, 2x plus 3y equals 5, along with 7x plus 11y equals 13. None of these variables would be nice to isolate. If we isolated the x here, we'd end up having to divide by 2, which would make a mess. If we isolated this y here, we'd end up at some point having to divide by 3, which would make a mess. And the same thing for this x and for this y. So something like this one right here, I wouldn't want to solve it graphically. I also wouldn't want to solve it using the substitution method. Instead, we need another algebraic method called the elimination method.